Alright everybody, so maybe the question everyone's asking, is the SLS4ALL Inova SLS printer worth it? Well, for me, I would say yes, because I was able to get an SLS printer at a quarter of the cost that prints at the same specs and quality of the competition that's out there. Now, I'm going to deep dive though a little bit more into some of the differences and the pros and cons between the Inova unit and the FormLabs and the Sinterit units. First, let me say I don't ever think complete SLS system will hit the market at a hobbyist price of under $4,000. Now before you get all high and mighty on me and say, oh, the Micronics unit was out there and they were selling it for a lot less, and I'm going to tell you right off the bat that was a Kickstarter price. That was something where they funded and probably was just recouping their costs. If the Micronics unit was ever going to go to market, they would have to include their material costs, their assembly cost, labor cost, overhead, warranty cost, all those things that needed to support a project and make money and margin. I would imagine that would have been priced when it hit the market for a fully assembled product at around $10,000 to $15,000. In my opinion, the main reason why FormLabs purchased Micronics was to prevent a competitor from buying them and putting out a $10,000 to $15,000 assembled SLS printer out there that becomes at a price point very appealing to small to mid-size companies, startups, educational institutions. And of course, that would erode FormLabs' margin and market share, so getting them off the market like that was strategically a smart move for them. So really it begs the question, is there a market for a commercialized Inova SLS printer selling for $15,000? I would say there probably is. It's possible. So only the market can really answer that question. Now, the competitive landscape has changed somewhat since I bought and assembled the SLS4ALL unit. In my very first video, I showed you this page of the two entry-level comparative systems from FormLabs and Sinterit. They were the Fuse 1 and ELISA, respectively. Well, since then, FormLabs has discontinued the Fuse 1 with a 10-watt laser, and now they offer this Fuse 1 with a 30-watt laser for entry price point at $25,000. Sinterit's website shows the ELISA sold out, and when I did further research, it was shown it was replaced with the ELISA X, which also has a 30-watt laser, and that competes with the Fuse 1 model at about the same price point. Now, Sinterit has recently introduced the Suzy model here, which is about $5,000 less than their ELISA X, and it appears to match all the specs of the ELISA X, but it prints only in a normal air environment. It also only uses one powder. It's the Sinterit's PA12 industrial powder. Okay, so with that aside, let's look at some of the key differences with Inova and the other units. And I'll start with the kit versus the fully assembled printer. Let's look at the full Inova do-it-yourself kit that sells for around $7,000 plus taxes and any tariffs at this time. Compared to a fully assembled competitive unit around $25,000. Now, if you built the CNC lathe, the do-it-yourself type, or a 3D printer, an FDM 3D printer in the past, and think this is just another do-it-yourself kit, then you have a rude awakening. This kit is not even in the same ballpark as those CNC lathes and FDM 3D printers. My intent is not to scare you, but just make sure you're thoroughly prepared for what you're getting ready to get into and the time commitment. There are 534 main components in this kit, along with 1,400 pieces of hardware to connect it all together. So during the process, you need to make sure you have the correct part, the correct orientation, the correct screw, and a number of other things when you assemble this. All the electrical, heating, and optical components all need to be hooked up properly and tested for continuity, impedance, and ensure there's no short circuits. I mean, accuracy and precision are important here. This machine is meant to be very high definition compared to FDM. So every little thing you do can impact the quality of the parts. Then after you get it all assembled, there's a setup and calibration process that's critical to make sure you get this done right, to make sure your galvo mirrors are set properly, your temperatures are properly being recorded, so that when you run your first prints, everything will go well. That's a critical process. Now, fortunately, myself and others have given a lot of input into the assembly. My assembly videos that you watch will help identify areas where you avoid some mistakes in that process. But the online assembly instructions are just flat out awesome, and they've obviously have improved with these iterations. There's also enough machines out there in use today where our feedback to the founders, Thomas and Pavel, have led them to improve the software and firmware so that now you can pretty much start a print and go through error-free and get great quality prints. I mean, that's where I'm at today. Everything I print today has been pretty much spot on. Perfect. It took me a little while to get there, but my early work is probably going to save people that buy this kit a lot of pain that save them pain that I had to go through that they won't have to. So the next question is then, was it worth saving $18,000 to build an SLS printer from a kit versus buying a fully assembled one from FormLabs or Sinterit? Well, only if Inova does what it says it should do and it's supported by its makers. In my opinion, both those criteria have been met. I believe in this unit enough that we plan on buying another one of these SLS printers, assemble it from the full kit, and use it and dedicate it to a different type of nylon powder, maybe a glass filled or carbon filled, depending on our customer needs. So I do want to mention the do-it-yourself kit that's available for around $3,900. Now this kit, it comes with all the electronics and optical and linear techniques and so forth, but then the do-it-yourselfer has to provide all the rails, the frame, all the aluminum sheets, and do all that machining and fabricating of those type of components. And that includes the aluminum, and then they have the high pressure laminate they use in their system called HPL. It's 4mm sheets. Now, if you live in the US, I caution you on buying the do-it-yourself kit, because I looked at trying to acquire 4mm HPL. There's no US distribution sources at this time. I reached out to several European resources, and frankly, by the time the quantity you buy and shipping from overseas, it just financially and logistically just doesn't make sense. So until there's some sort of material that could be used in place of the 4mm HPL for US customers, I think you're going to find yourself that that is not the kit that you want at this time. Okay, let's talk about the build volume of the Inova compared to the others. So let's take a look at this sheet again. You can see actually, in terms of total volume, the Inova is about half the build volume of the others. Now, depending on the size of the parts that you're printing for yourself or your customers, this could be a limiting factor. Now, most of the build volume difference, though, is in the total depth. So the competitors have about 4 to 5 more inches of printing depth. The Inova has a printing depth of about 7 inches, whereas the others, like I said, are around closer to 12. The Inova has a print area is almost 6 inches. It's 5.9 by 5.9 inches, and that's length width. The FormLabs, you get about a ½ inch more, both in width and length for the FormLabs unit. The Sinterit's kind of unique. You can see it's non-symmetrical, so it's 5.1 inches one way, 7.1 inches the other way. Now, on any of these units, if you orient the part on a diagonal in the print chamber, of course you can get a little bit bigger prints. The biggest advantage, though, of having a larger build volume is basically just allowing production of larger components or printing more smaller parts in a single print job. Now, you could say that you could buy 2 of these Inova printers and you pretty much match the volume, and you still have less the cost of the other units. So it's just kind of one way you look at it, but if you're only looking to spend $7,000, you will have less build volume. It's just a fact here. Do I think that's a huge limiting factor for this unit? I don't think so. For most of us, small to mid-sized businesses, using it for prototyping, most of the time this fits within what we need. Okay, let's talk about print speed. Now, both the competitors you see in the chart, FormLabs and Sinterit, they can print faster, mainly because they upgraded to the 30-watt laser. So the FormLabs boast a print speed up to 20 millimeters per hour, and Sinterit says up to 14 millimeters per hour. And usually these are measured at some sort of part packing density around 25%. So for the Inova, initially when I was doing all my runs, I was seeing closer to about an 8 millimeter, but since we've tweaked some of the software and some changes with Pavel, now I'm seeing up to 10 millimeters per hour print speed. So for the most part, like I said, it's about half that of FormLabs, a little bit closer to the Sinterit. But to be honest with you, for me, it's not such a huge difference. Most of my print jobs have been under about 100 millimeters of depth, so I can usually print early in the morning, and I have prints completed by the end of the day, and then I can just get them cleaned up the next morning. So I still, within 24 hours, I get the prints that I need. For the Inova, between the preheat now, between what I've optimized with the preheat and the bed prep, we're talking about an hour and a half between those two steps. And then you've got the print time, and then it says it takes a minimum of 2 hours to cool. To be frank with you, it doesn't matter what print depth I've been at, it takes pretty much a minimum of 3 hours. For anything that takes longer than 4 hours to print, it says that it should take half the time to cool than it does to print. So you can imagine it. I mean, if you build up this print chamber full of parts, use the total volume, it would basically take you almost a day through the night and have parts maybe by the end of the next day. So another big difference between the Inova and the FormLabs and Sinterit models is you'll see in the recoater. So the Inova uses a blade system, and the other two use a roller type system. Now, I'm not an expert in this area. I just know what I know from the Inova unit. So I just kind of checked the AI, Google, and asked it, what's give me the pros and cons. So basically this is what it says. I'm just going to read it right to you. It basically says the advantage of a blade is consistent layer thickness. It has a higher powder bed density and it improves the part quality. And it says the biggest disadvantage is that if the print layer deforms, the blade has the opportunity to scrape off or deform that layer on its next pass. Now, here's what I'll tell you about that. If your settings are correct and if your temperatures are correct, you should not have any deforming on the surface layer, so when the recoater blade goes across, there shouldn't be any issues there. So I would say that I haven't had any issues with the top layers deforming. So I haven't had any scraping issues. So I would say that the roller kind of could potentially hide an issue in your temperature settings if you have some sort of deformation on the level. So yes, that is the disadvantage of potentially scraping off. Now I will tell you that if you have contamination, if you didn't properly sieve out your powder and when you refreshed it, if you have contamination in the powder bed, then when the blade goes across, it could actually roll that piece of contamination across the print bed, and it could either gouge it, because that contamination drags across that layer and creates that line through it. I've had that happen, and normally after about the third or fourth pass, after the gouge is made, it fills back in with powder. And fortunately, if it's on the internal inside of a part while it's being made, you really don't notice it at all. Obviously, if it's on the end of a part and on the surface, it'd be a surface defect. Now, in terms of the rollers, it says here that rollers tend to have a more consistent powder distribution without catching on any deformed layers. But it does say, however, contaminated rollers can create surface irregularities on printed parts. So that's the problem with rollers. And if you look at FormLabs' website, they have a whole troubleshooting guideline around cleaning and taking care of your roller because of contamination. For the same reason as a recoater dragging, a blade dragging contamination across the surface, a roller contaminated on the outside can just imprint or add irregularities into that surface. So I would say that if you're concerned about a blade on the Inova, you shouldn't be. I've been getting consistent results, and if you have your settings correct, you shouldn't be getting any deformed layers in the first place, and you'll see consistent layers. And you've all seen my prints and the layers, and they look fantastic. It's industrial quality. So I don't necessarily see it as a disadvantage, but if that was a concern of yours, that's what I've experienced to date. So let's talk about patterns that you can use. Now, the Inova SLS printer is an open source printer, so you can use a wide variety of powders that melt below 200 Celsius, and you just basically have the ability to adjust all sorts of parameters, the laser energy density, the print bed temperatures. All those parameters you have control of and can get dialed in. The Inova printer comes with a FormLabs PA12 profile ready to go. I've tweaked that based on my machine to optimize it, but it gets you started. Pavel and Thomas have been experimenting with TPU powders recently, and they've you've probably seen some of their displays on their Facebook page, but they basically have dialed in those parameters now, so that'll be another profile to be able to be used. I've talked to a couple other persons that have these machines, and they've used other powders as well and been able to get them dialed in. Now, if you look at the FormLabs printer, it only uses FormLabs basically branded powders. So you can't change any of the parameters in their settings to use different powders. However, they do say that you can buy a one-time license to be able to use other powders outside, and I think that license was close to another 10 to 12 grand. So, you know, another opportunity to get income, and you can buy the Inova and already have that capability. The Sinterit also offers a open source type system, so they claim that you can also change their parameters to be able to use a variety of different powders. So it's basically, I would say, on the same level as Inova. So let me talk about overall print quality. Now, I can only speak to my machine compared to parts that I've purchased from third party like Xometry SLS parts. So as you saw through my videos, once I got my laser energy density and my layer temps dialed in, I personally can't tell any difference between the parts I print and the parts I've received from Xometry. I've also measured the part density well within the range where it needs to be at. I've measured the tensile strength. I'm in the range where those need to be at. So overall, these parts, if you're concerned about using these for customers for small batch production, or potentially using them for rapid prototyping, whether in-house or for your customers, you should have the confidence that what you make will be at the same level and quality as what you can get on a FormLabs and a Sinterit machine. All right, so basically my final thoughts on this is, as I told you in the beginning, I'm quite pleased with the overall performance and capability of the SLS Inova 3D printer. For the cost of $7,000, a month of my time to build, a few more weeks to kind of get it all dialed in, I feel like it was worth the savings. Now, I could basically buy 3 more SLS printers for what I saved in lieu of, you know, a fully assembled FormLabs or Sinterit machine. I learned a lot from building the first one. In fact, Thomas and Pavel have learned a lot from the machines that they put out there from all of us early adopters. And this machine is only getting better as the community comes together and gives their feedback, and software and firmware and those type of things will make these machines continue to get better and their capabilities and extra features. So really it comes down to, if you're not the sort of person that wants to build their own, I think that if SLS4ALL decided to partner with someone to build a commercialized unit, fully assembled, to compete with FormLabs and Sinterit at a price point, I think they could do it at a much lower price point. And I would tell FormLabs and Sinterit, look out, you have another competitor. Well, that's all for today, and look forward to my next video.